In this video, we're going to look at parallel and perpendicular gradients. Now, parallel gradients, firstly, this should be revision for you as this was covered in National 5. So just a reminder about parallel lines. So here is a pair of parallel lines, and you can see that the slope of those lines is exactly the same. It's just that the position of the line is slightly different. And that means that parallel lines then have equal gradients. So it's always something to bear in mind because there are some straight line questions at higher which might mention parallel lines, so you need to remember that those have equal gradients. Now, I'm going to get you to do a series of different tasks here, and for that each time I'll give you the task, I'll ask you to pause the video, write your answers down and then come back and check those, and it will just develop into perpendicular gradients. So task 1. Here are 4 products which I would like you to calculate. So if you pause the video and go and do these just now. Okay folks, welcome back. So the first one, hopefully you will have got -1, because -4 multiplied by 1/4 is -4/4, which simplified is -1. For the second one, when you carry out that product, you would also get -1. The same for the third one, also -1. And the fourth one is also -1. So a bit of a pattern going on here. Now, task 2. So we've got a row of values that I'm calling A, a row of values that I'm calling B, and then I've got a row of values for A multiplied by B. So the product of the first 2 rows, like so, and those are all -1. So I want you to fill in the blanks. So again, pause the video and fill in the blanks for me. Okay folks, welcome back. Hopefully you got on well with that. So for the first one, for B, hopefully you've got -3/2. So firstly, we know that A is positive. We know our answer is negative, so that means B must be negative. Now secondly, hopefully you've noticed from what we did in task 1 that the numerator of one of the fractions is the same as the denominator of the other fraction, and vice versa. Same here, and same here. And that gets us our -1. So hopefully you've done that here, 2/3 and then -3/2. So that carries on. For A, we should have had 9/4. B in the third one, we should have had 1/5. A in the fourth one is 2. And B is Q/P. So hopefully you managed those. You're starting to see some sort of pattern developing here with what we're doing. So if the product of A and B is -1, which for all the questions we've done so far that is the case, so if that product is -1, then A is said to be the negative reciprocal of B, and B is the negative reciprocal of A. Now, you've met reciprocals before when we have looked at dividing fractions. So some of you will know that as when you divide a fraction, you flip the fraction you're dividing by and you multiply. Well, actually, you're actually multiplying by the reciprocal there, which is the correct methodology. So here we are looking at negative reciprocals, as you can see. Okay, now we've got task 3. I want you to find the negative reciprocal of the following fractions, and then also task 4, find the negative reciprocal of the following integers. So pause the video just now and go and try these. Okay folks, so for the first one in task 3, we've been given 3/4. The negative reciprocal is -4/3. For And that's because if we multiply those together, we get -1. For the second one, we should have got 2/7, and again, that's because if we multiply them together, we get -1. For number 3, it should be +6/5. For number 4, -11/4. And task 4. Now, obviously, these are all whole numbers, as you can see, apart from number 5. So the first one, we need to multiply by -1/3. That's the negative reciprocal. And 3 multiplied by -1/3 gets us -1. For number 2, the negative reciprocal is 1/4, because that product gets us -1. Number 3 is 1/15. Number 4, -1. And finally 0. Well, 0 multiplied by something gives me -1. But I know that if I multiply 0 by anything, I get 0. So in actual fact, if you have 0, you can't find the negative reciprocal of that. It's undefined because you can't divide by 0. So that's why. So that'll lead on to something that we're going to look at in a wee minute. So you're probably thinking just now, folks, this was a video on gradient and we've not actually really talked about that yet, and you would be right, but all of this is leading up to what we're going to look at here. So here's a line, AB, and here's another line, CD. And if the gradient of AB multiplied by the gradient of CD is equal to -1, then the lines AB and CD are said to be perpendicular. So those lines are said to sit at right angles to each other. Now, you could probably have seen that from the diagram there before the right angle went in, but obviously we know sometimes diagrams aren't accurate, so this numerical method of checking that there's a right angle is very useful as well. Conversely, if AB and CD are perpendicular, so if we know that those are right angles to each other, then we know that their gradients multiplied together are going to give us -1. So, horizontal and vertical lines. Now, if we've got our Cartesian grid here, here's a horizontal line. Now we know that horizontal lines have a 0 gradient, so m equals 0. We know that their equation is y equals something, so say this was 5 here, and we had the points, -3,5, -2,5, -1,5, 0,5, etc. That equation would be y equals 5. But the line which is perpendicular to that, so the line that sits at right angles to that, is a vertical line. But vertical lines have an undefined gradient, their equation being x equals whatever it is, whatever point it's passing through on the x-axis. So earlier when I said to you what is the negative reciprocal of 0, and we realised that we couldn't do that, this is why. Because here's the gradient 0 of the red line, and the line that sits perpendicular to that is the green line. And we know that because that's vertical, it's got an undefined gradient. Now, this is very important, folks, because it's something at higher that a lot of people always forget. So they forget that you can't find the negative reciprocal of 0, and they forget that a gradient of 0 is a horizontal line. So it's worth remembering this, worth copying this slide down in particular, as well as the previous slide, I should have said that. You also need to remember that horizontal and vertical lines have equation x equals for a vertical and y equals for a horizontal. Okay, so let's look at an example. So given that t is the point 1, negative 2 and s is negative 4, 5, find the gradient of a line perpendicular to st. So the solution then, we first need to find the gradient of st. So remember, it's the change in your y ordinates over the change in your x coordinates. So that's 5 minus negative 2 and over negative 4 minus 1. So that gradient is 7 over negative 5, which written correctly is negative 7/5. Now, if we know that that is the gradient of st, we are looking to find the gradient of a line perpendicular to st. So the perpendicular gradient, we use this wee symbol here to denote the perpendicular. So the perpendicular gradient here is 5/7, since the gradient of st multiplied by the perpendicular gradient is equal to negative 1. So this is a statement that we need to use in higher. It's very important because sometimes the SQA will ask us for statements like that in our answers in order to gain all of the marks available for a question. So it's worth remembering this statement and making sure that you put it in every single time you find a perpendicular gradient. So our final answer here, folks, was 5/7. So if you pause the video just now and copy this example down in your notes jotter. Okay, so example 2. Triangle MOP has vertices M negative 3, 9, O 0, 0 and P 12, 4. Show that the triangle is right angled. So for this question, obviously we're learning about perpendicular gradients, so we're expecting two of the sides of the triangle for their gradients to give us negative 1 when they're multiplied together. Okay, so that will show us that the triangle has a right angle in it, and therefore it's perpendicular. Those sides are perpendicular to each other, and therefore that the triangle is right angled. So we need to firstly examine the gradient of each of the sides of the triangle. So we'll firstly have to look at MO, that line, then OP, and then MP. So firstly, the gradient of MO is going to be the y ordinates on the numerator, remember, so 0 minus 9 all over 0 minus negative 3. That gives us negative 9/3, which simplifies to negative 3. Okay, so that's one side of the triangle, that's its gradient. If we now look at the gradient of OP, we've got 4 minus 0 over 12 minus 0, which is 4/12, which we know is 1/3. And finally, the last side, MP. So the numerator then is the y ordinates, so 4 minus 9 all over 12 minus negative 3. So that gives us negative 5 over 15, which simplifies to give us negative 1/3. Now, if we look at these three gradients then, for a pair of these lines to be perpendicular to each other, i.e. so that the triangle has a right angle, the product has to be negative 1. So if we look at the negative 3 here and the 1/3, since the product of negative 3 and 1/3 is negative 1, the lines MO and OP are perpendicular, and therefore triangle MOP is right angled. So it's really important, folks, as well for this question that we have a statement similar to the one that I've got at the bottom here to justify your answer. It wouldn't have been enough here just to write negative 1 -3 multiplied by 1/3 equals -1. We need to then refer that back to the question and see what that actually means. So we're actually concluding that MOP is right angled. Now, I suppose one other way to look at this, just to confirm what we've done, is to draw the triangle. Now, you don't have to do this for every question, but it's always good to have a diagram as well, so you can actually visualise what is going on here. So you can see the sides here, there's O, that's M, and that's P, and it was between MO and OP where the right angle was occurring. So MO and OP here, and you can see that that is a right angle. So it just confirms exactly what we've done as well. So just now would be a good idea to pause the video before the screen goes blank and copy this example down in your notes jotter as well, folks.